Okay, so what we're going to talk about today are, our objective is to learn how to now not just multiply a monomial times a monomial, because we've been doing that, but what if we're going to multiply a monomial times a polynomial? What if we multiply a binomial times a binomial? What if we multiply a trinomial times a trinomial, or a trinomial times a binomial? What are we going to do? So what I'm going to do is teach you 3 different strategies, and then you kind of have to fill out what seems the best for you. And then that may be the strategy that you're going to continue to use. And it doesn't matter what kind of problem I give you, the same strategy can be used over and over and over again. Okay? Now, I'm also going to, as we go through some practice problems, maybe not tonight, but another night, I'm going to pull out certain types of problems and look at their answers. Because there may be some patterns that you can see that is going to give you a faster way of coming up with the answer, okay, than involving one of these strategies. Kind of like what I was talking about in geometry class, we have postulates and theorems. Postulates are things we just accept to be true. Theorems are things we have to prove. The theorems generally provide us a faster way of getting an answer. Okay? Without that theorem, I can still get the answer, it just takes me longer. So again, that's what we're looking for, is can we see a relationship and can we apply a rule to that relationship? All right? So let's go ahead and get started. Today our objective is to understand how to multiply a polynomial by a polynomial. Now, when I say that, remember, a polynomial could be a monomial, could be a binomial, could be a trinomial, could be anything beyond a trinomial. Okay, so that's our overriding objective. And then we've got 3 we've got methods that we're going to review. We'll call one of them, let's see, what do I want to call? Distribution. And I'm going to put in parentheses repeated. Okay, that would be one strategy we're going to work on. The next strategy that we'll work on would be, it's called the area model. And I'm going to call it, I cannot stop myself from calling this, I'm going to call it the matrix. Okay. And then the third method is going to be column multiplication. Just like what you've learned for years when you're multiplying a 1-digit and a 2-digit, 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 3-digit, and so on and so forth. Okay? So those are the methods that you're going to see today. And so there's not going to be a whole lot of write down these words. It's going to be more, let's look at these methods and apply it to a problem. Okay? So here's the one thing that's going to be true no matter what method you use. Okay? Each term in one polynomial must be multiplied by each term in another polynomial. That's the whole gist. Since we can get to quite a few terms, these 3 strategies are going to help us stay organized and make sure that everything gets multiplied by everything. Okay? So that's the whole gist. That's the big, that's what you're doing. Making sure everything gets multiplied by everything. Bottom line. Okay? Now, today our main focus is 2 types of problems. A monomial times a polynomial and a binomial times a binomial. Okay? We will get into polynomial times polynomial, but again, the strategy doesn't change. The directions don't change. The process doesn't change. The notes aren't going to change. It's just the examples are going to be different. Okay? So let's start with the simpler. We've got a 1 term times a multiple term. Okay? So the directions for all of these are going to be the same. They're going to say simplify. And simplify means do all the math that you can do until there's no more math to be done. That was a strange sound.
That's my key. It fell out of my pocket.
Oh.
It's a really cool key. Has Scooby-Doo on it.
Okay. Alrighty. So I'm going to start with maybe not such a simple problem because you're my advanced kids. Oops. So we have negative 3x cubed y squared, and I want to multiply it by 2x squared y cubed minus 4xy plus 5y squared minus 1. So notice this problem is written, the polynomial is in descending degree order. And you say, well, wait a second. It goes on the y's 3, 1, 2. How's that descending? Because if I have more than one variable, I can't descend all the variables. I pick one variable, and we tend to pick the first one or the one that has actual exponents. So if you notice on your x's, it goes x squared, x to the first, no x. And at the very end is a constant. Okay, so we are descending degree order. So this problem really lends itself to simple distribution. So all distribution says, so I'm going to highlight distribution. Method. What it says is you're going to take your negative 3x cubed y squared. You're going to multiply it by each term in the polynomial. So you're going to multiply it by the 2x squared y cubed. And then you're going to multiply it, wait a second. Let's do this. What I like to do is grab the sign that's in the polynomial, and I like to write that next. And then multiply it by the negative 3x cubed y squared. And then, since I've already counted for the sign, I'm just going to write 4xy. And then I'm going to grab this plus, and then times negative 3x cubed y squared, and then he's going to get multiplied by the 5y squared. And of course, I'm running out of room, so that's okay. We'll just do it underneath. So we grab that negative. Actually, let me give myself a little bit more room. And then we have the negative 3x cubed y squared, and we're going to multiply it by 1. So the other option that you can do is always write plus between all your little mini multiplication problems and put the sign attached to the actual number. That's your other option on how you do this. And then we just start doing math. Okay? So we have a negative 3 times a positive 2, so that gives me a negative 6. X cubed times x squared, I add the exponents, I get x to the 5th. Y squared times y cubed, I add the exponents, I get y to the 5th. Now here I see a double negative, so I write plus. And now instead of doing a negative times a positive, I just have a positive, right? So I've got 3 times 4 is 12. X cubed times x, add up, I get x to the 4th. Y squared times y, add the exponents, I get y cubed. So again, I'm dealing with my signs first, so then I don't have to worry about it. Here, the signs are different, so I'm going to write minus. So since I've taken care of the negative already, I'm just going to be distributing the 3 times the 5. So 3 times the 5 is 15. X cubed times, there's no x there, so it's just x cubed. And then y squared times y squared gives me y to the 4th. And then if you notice in this last problem, we have a double negative, so we're just going to get a plus 3x cubed y squared. Now, because my polynomial had no like terms, multiplying each of those terms by the same number is not going to give me like terms all of a sudden. So my answer can be something big, long, and hairy. Okay? So that's what distribution looks like if I have a monomial times a monomial. All right? Now, I am going to show you kind of an interesting twist on that problem, is that we can do a combo problem with this as well. Combo problem would be something like 5a squared times the quantity a plus 7 minus 2a times the quantity 5a squared minus 3a plus 7 plus 1/2 times the quantity 4a cubed minus 32. Okay? So what I have is a lot of mini problems. So what I'm going to share with you is another strategy, which would be that column multiplication. Okay, and what I would do for column multiplication is I would take the monomial and I would write it underneath. And now I'm going to multiply. Basically, it's another way of showing distribution. It's just another way. Okay, so here I'm going to put a negative 2a, and here I'm going to write a 1/2. So when I have 5a squared times 7, that gives me 35 a squared. When I multiply, 5a squared times a, I get positive 5a cubed. And now I'm going to multiply by negative 2a. Negative 2a times positive 7 is going to give me a negative 14a. And here, a negative 2a and a negative 3a is a positive 6a squared. And then a negative 2a times a positive 5a squared is going to give me a negative 10a cubed. Now, half of negative 32 is negative 16. Half of 4a cubed is going to give me positive 2a cubed. Now, how this problem is different than the last problem, because I had 3 individual problems, I may end up with like terms on this one. So let's look for those. I'm going to look for the highest exponent, which is a 3. And I ended up having 5a cubed, negative 10a cubed, and positive 2a cubed. So what's 5 take away 10? Negative 5 plus 2. So we end up with negative 3a cubed. So let's look for the next exponent. Let's look for a squared. So we got a squared. We got 2 of them. What's 35a squared and 6a squared? So positive 41a squared. All right, let's look for a's. That's it. I only got 1 of them. So I just write negative 14a. And then I have a leftover guy. He's my constant, and he goes at the end. So we got an Easter egg answer of negative 3a cubed plus 41a squared minus 14a minus 16. And again, it's written in descending degree order. Okay? So that's a different way. Now, it's not as impressive looking at these strategies when you've got one term times multiple terms. So let's deal with that whole notion of binomial times binomial. How many terms are in a binomial? 2. So I've got a 2 terms by 2 terms. Okay, so let's do some of those. So let's see, the first one that we haven't talked about, strategy would be the area model, or as I like to call it, the matrix. You'll understand why when you study matrices in Algebra 2. Okay, so I'm going to demonstrate this one 3 ways. Okay, I'm going to demonstrate this one 3 ways, and then we'll do some other practice problems. Okay, so first way, let's do the area model, aka matrix. So what I do is I'm going to create a big box, and in that box I'm going to have as many columns as I have terms from one polynomial, and I'm going to have as many rows as I have terms in the other polynomial. So since I have 2 terms here and 2 terms here, I'm going to create a 2 by 2 matrix, or fancy word for box. So it's going to have 2 across, 2 down, for a total of how many boxes altogether inside? A total of 4 boxes. Now you don't want to write this really small because you're going to be putting answers in here, and we're going to take those answers and create our final answer through it. So I'm going to take one of the polynomials, it doesn't matter which one, and I'm going to put the terms across the top. So I'm going to take the first one, the x plus 5, and I'm going to write x and then plus 5. So it's really important that you include the signs for each of the terms. Notice the x, I didn't put one because he's positive, but I want to make sure that I know that that's a positive 5. So then I'm going to take the second binomial and put it down vertically. So now I have a 4 by 4. So the reason why they call this the area model is because what I'm asking you to do is figure out the area of each box. So this box has dimensions of x times x, which gives you what? X squared. Okay. This box has an x times a 5. So what's that going to give you? A 5x. Now I'm going to put the sign with it, so plus 5x. Okay, and then this box down here has dimensions of 7 and an x. So when I multiply them, I get positive 7x. And then the last box has dimensions of a 7 times a 5, which gives me positive 35. Now, looking at this matrix with the 4 terms inside, you look for anything that would be considered a like term. Where do you see some like terms? On this diagonal, we have some like terms. Okay? So my final answer, starting in the upper left box, descending degree order, I have x squared. Then I combine a positive 5x and a positive 7x for a grand total of a positive 12x. And then the bottom right corner is going to be my last term. And there you go. Okay? So that's the area model, the one we hadn't talked about yet. What I love about the area model, it works for everything. And the way I'm describing our 3 strategies, it works for everything. Okay? Let's talk about columns. Column multiplication. Hello. Give me color. Thank you. The idea behind column multiplication is that you must write your polynomials in descending degree order for this to work best. Ours already were. And now what we're going to do is just what we would if this was 12 times 37, is I'm going to start on the bottom. I'm going to start on the bottom with the guy that would be, quote unquote, the one's value. Okay? But actually I didn't circle him properly because that's what I'm going to start with my multiplication. I'm going to multiply everything on top by positive 7. So I just start with the value that's farthest to the right. Okay, so positive 7 times positive 5 is positive 35. Positive 7 times x is positive 7x. Now, what's different between this and multiplication with numbers is that I don't have to put in a x to hold a term or 0 to hold a term. All I'm going to do is put like terms underneath each other. Okay, so I have x times positive 5 is going to give me a positive 5x, so he lines up with a 7x. And then I have x times x is x squared. So then I just add up. And again, I'm not going to have any carrying, so I can add from either direction. And I get exactly the same answer. Okay? Now, distribution. With distribution, sometimes it's just you got to do it more than once. So with distribution, we're going to do the same ideas, but it's just a different way of showing it. So I'm going to, when I distribute, I'm going to start with my first polynomial, and I'm going to start with the first term in my first polynomial. And then I'm going to multiply them by everything in the second polynomial. So I'm going to multiply x times x, which is x squared, and x times positive 7, which is positive 7x. So I've now exhausted all the multiplication I can do with that guy. So now I'm going to do the multiplication with the positive 5. Positive 5 times x is positive 5x, and positive 5 times 7 is positive 35. And then I look for any like terms. And they tend to be, if my polynomials were written in descending degree order, they tend to be right there in the middle. And I get for my answer x squared plus 12x plus 35. Now, your brothers and sisters, your moms and dads, your grandmas and grandpas all learned a particular mnemonic device to help them remember this distribution method. And they learned the term FOIL. Okay, so I'm going to write it down, but I'm going to tell you, according to Common Core, they don't want us really talk about it. And what FOIL stands for is first, outer, inner, last. And so, and I'll color these up. When they're saying first, they want you to multiply first term times first term. That's your F. Then they want to do outer, which is going to be first term times the last term of the other guy. That's your outer. And then they want you to do inner. I'm going to do a different color just so it can stand out a little bit better. Inner is going to be the 5 times the x. That's your I. And then last is going to be these. So I'll circle up all those letters. Now, again, FOIL only works for a binomial times a binomial. Distribution works for any size polynomial times any size polynomial. The area model / matrix works for any kind of polynomial times any kind of polynomial. The columns work for any kind of polynomial times any kind of polynomial. So that's why with Common Core they resist wanting to teach you how to do one specific type of problem using that idea of FOIL. But Mr. Johnson and I were talking about it, like we feel like we're ripping off a generation if we don't tell you this word, because if you say FOIL, older people go, oh yeah, FOIL, I remember FOIL. But if you say, hey, I learned the area model today to do my multiplying polynomials, they're going to look at you and go, what? You know, and matrix in particular, that's kind of my word for it. And then you might, well, I can do column multiplication with polynomials. What? You know, they're not going to understand what you're talking about. But FOIL, they get it. But again, FOIL is very limited to only a 2 by 2. Okay? Yes?
Wait, so FOIL is only for distribution?
FOIL is actually, it looks the most like the distribution method, but all it is, it's multiplying 2 terms by 2 terms. And it only works for that. I cannot use FOIL if I have a 2 term times a 3 terms, because there's not enough letters. Okay? So that's why FOIL, again, just write a passage, you should know what it means. But to me, you got to just know the other strategies. So let's do a hairy problem, and we'll end with that. Here's your hairy problem. Oops. Three x squared plus 7y squared times the quantity x squared minus 4y squared. So what makes this hairy, we've got coefficients for most of them. We have different signs. We have 2 different variables. So we've got a lot of things to pay attention to. So here's the drill on your homework. You got to pick your strategy. I would recommend you kind of play with each of them until you feel most comfortable with one, and then just kind of use that one if that works with it. In the beginning, a lot of people like the matrix, but then they realize it's taking me too long to draw my box and do all that stuff, so people tend to go towards just distribution. Okay? You just got to remember. But the key thing about distribution, I would at least do links. Okay? So I'm going to show distribution on this one. What's 3x squared times x squared? Because I apply my rules. When I multiply monomials, I add my exponents. Okay? Now, this is where it gets a little bit, I'm going to do this time a little differently. I'm going to write the operation as always plus, and I'll attach the sign to the individual numbers. Or actually, yeah, we'll do it that way. No, we'll do it this way. Sorry, I'm thinking again. So now we're going to multiply 3x squared times negative 4y squared. What's that going to give me? Yeah, negative 12x squared y squared. So the hardest thing was signs and coefficients. Okay? Then we're going to multiply 7y squared times x squared. What does that give me? Positive 7x squared y squared. Always keep the variables alphabetical. And then the last thing we're going to do would be 7y squared times negative 4y squared. What is it? Okay, negative 28y to the fourth. So the only thing I need to look for are like terms. Okay, do I have them? Yeah, what are they? Those guys right there. Okay. So my answer? 3x to the fourth. What's negative 12x squared y squared plus 7x squared y squared? Careful. Careful. Negative 5x squared y squared. Negative 12 plus 7 is negative 5. The variables don't change. And then we have a minus 28y to the fourth. Now, what do you need to show on your homework? All of that. You have to show me original problem. You have to show me what you get when you do out the multiplying, and then you have to show me the final answer. That's the minimum, okay? Or those three. So good luck with the homework.